What's going to happen in about 5 billion years from now is going to expand. In fact, even in the shorter term, it's going to get too hot for us.
Become a red giant.
And it's going to swallow Mercury and Venus and probably Earth. Swallow Earth.
Probably not the time to be here then.
Definitely not. We'll be gone. Well, we'll be space-going race or else we'll be extinct.
Yeah.
And then maybe even Mars. That's about 5 billion years from now, and it's about 5 billion years old. So it's sort of halfway through its lifespan.
OK, so we've got a bit of time to think about that.
Yeah.
So when it gets larger and larger, swallows up those close planets then in its neighbourhood. And what happens?
Then it shrinks down after all of that, and it turns into a white dwarf, roughly the size of the Earth, but about 0.7 of its mass, with a surface temperature of about 10,000 degrees, and it'll stay like that for tens of billions of years, and maybe it'll pick up some other planets. Life is long.
Let's go back to the beginning then. Do we know how it formed?
Yeah, coalescence, we're pretty sure. So in the beginning was the Big Bang, and we're pretty sure that the Big Bang happened. We could be wrong, but we're pretty sure it happened. And there's a whole bunch of time steps along the way where we know different things happened. So at around 377,000 years, the first atoms of hydrogen and helium formed. Around 400 million years of age, the first generation of stars formed. First generation. Our sun, third generation. So the first generation sort of, you know that old rule, the rich get richer and the poor get children. Yeah. So if you've got stuff floating around in space and there happens to be a bit more stuff in one place, well, then it acquires more stuff by gravity.
So would this have produced a number of suns?
A number of big suns.
So they have been flung off because...
They coalesced from the hydrogen, and they were the first generation of stars.
So you're saying our sun is likely to have a brother or a sister?
Yes,
but
we formed.
The nearest star is what, Alpha Centauri?
4 light years away. So going way, way back, we formed in a big cloud of gas and dust, along with, we're pretty sure, 1,000 other siblings. And this big cloud of gas and dust had, certain elements in it besides the hydrogen and the helium. And that's a long time ago, 5 billion years, 4.7 billion years ago. So the galaxy, the Milky Way, has spun about 18 times. And we've gone looking, the field is called galactic archaeology, and we've managed to untwist the motion, and we've found 100 light years away a star which is very, very, very likely to have been our long-lost sibling, the same mixture of various elements in it, but 100 light years away. Our sibling. Unwound. And you think about it like...
Rewinding history.
Well, imagine you get a drop of dye, you drop it somewhere in the Pacific Ocean, come back a year later and try and find where those water molecules are. That's the kind of mathematics that the astronomers do. OK. When we come back to contemporary times then... What do we know about the sun? Because, there are so many mysteries about it. For instance, its surface temperature and its atmospheric temperature. Why is the atmosphere of the sun so much hotter than its surface? Nobel Prize. Nobody knows. So at the centre it's 15 million. Yep. Just below the surface is really hot. Surface is 6,000. Just above the atmosphere, million. 5,000 million. Why?
Would that not be like a flame? The heat of a flame. It's much hotter right at the very top rather than at the bottom of the flame. But that's chemical, which is so confusing, of course. So the scientists have been through 15 ways from breakfast, and they've got about 10 different theories, and one of them will turn out to be right, probably, or it might be just another one from out. We do not know why the atmosphere, 1.5 million degrees, is so much hotter than the surface, 5,000-6,000. Which is the reason why a spacecraft is going to be launched in a couple of years' time to try and work out some of these mysteries. We're going to go trying to solve these mysteries. And further down the line, we're going to need fusion for energy when we become space travellers. But for me, one of the amazing mysteries about the sun is that it has rain. There's rain on the sun. But not rain as we know it. Not water droplets. You're talking about plasma, aren't you? Yeah, so there's the 4 states of matter. There's solid, and there's liquid, and there's gas. And then there's plasma when you rip the electrons off from the central nuclei, and you just got a sea of nuclei and a sea of electrons, and that's what the sun is made of. And on Earth, we have the water vapour going up and condensing. On the sun, we have the plasma going up and coming down, but the scale is different. Firstly, it goes up 60,000 kilometres. The Earth is only about 12,000 kilometres across. Secondly, when it falls, the raindrops are not that big. They're the size of Tasmania. Right.
And then thirdly, as they're coming down at 50 kilometres a second. You think, wow, that's fast. It turns out it should be a lot faster, but they're cushioned by some sort of other stuff in the way that we don't fully understand.
Either way, probably not wise to be underneath one.
Oh, no, but it's amazing. There's so much more to know about the sun, which will then turn out that our great-grandkids will use this knowledge on toys that they're playing with in the backyard.
Dr Karl, very illuminating. Thanks very much.
Thank you, Dr Andrew.